Okay, welcome back to Chemistry Prep Station. Our last discussion was on gas law. So I've taken my time, though I took my time in that episode to explain what those laws simplifies and their equations for calculation, and also look at some past questions regarding those laws. So go over with the video, watch it carefully, and practice it by yourself. All right, so I'm going to continue from there, but this I will not go too deep. Just look at the slide. All right, the solution is already there. Studied it very well. This is under Graham's law of diffusion. It's still regarding what? Rates and mass, time and mass. So pay attention to this question. This is where JAM picked their question from Graham's law, because it's always confusing. All right, so if you solve number 17 very well, as you have seen on the screen, you will get 21 seconds. The steps are there. Please go through it very well. Then the next, another example, number 19 is already on the screen. This is under Gay-Lussac's law. All right, Lussac's law has to do with volume. Okay, I picked 20 study questions from gas laws, okay, to show you how these questions are being set and how to go about it. Now, let me just pick one of these. It's the same thing to discuss for Graham's law. So I'll go to question 20, question 19 and 20 that are the same. Just different approach, the same question. Now, 20 says, 30 cm cube of hydrogen gas was packed with 12 cm cube of oxygen at 110 degrees Celsius and 760 mmHg to produce steam. What percentage of total volume of gas left after the reaction is hydrogen? In this case now, you will not even talk of percentage if you don't even know the volume of the gas that is left over. So what do you do? First of all, write a balanced chemical equation for this reaction. You will have this 2H2 plus O2 give us what? 2H2O. Now, according to the question, what is the reacting volume? Yes, reacting volume here is what? Is 12. The mole ratio is here 2:1:2. All right, we are looking for the volume of the leftover what? Hydrogen gas. Don't forget. So if this volume was reacting, okay, to this, now what is the multiply this, all right, by the given volume of hydrogen gas. So if you multiply 12 by 2, that's how you have 24, all right, as a volume, reacting volume of what? Of hydrogen. Don't take note, you are looking for the leftover what? Reaction. So now go back to your question. You are given 35, look at it here, 35 cm cube hydrogen gas was packed with 12. All right, so now the gas that will be left over will be the gas, all right, that is 5 cm cube minus 24, that will give us what? 11 cm cube. Now, but the question says, what percentage? You get it. So now, take the percentage of this. 11 all over the total volume that was reacting, or that reacts with hydrogen, rather, divided by what? Or multiplied by 1000. That is how you get what? The percentage. Okay, so this one is very, very simple, but it's very tricky. You must really understand the question. It's one of the simplest gas law ever. So with these 20 questions from gas law, I believe you can solve any question regarding gas law in these forthcoming JAM exams. I will take you to the next topic, which is water and solubility. I will be so fast in this so that I can touch a little of the last topic for the day. All right, so what is structure of water? Water has two atoms of hydrogen and one atom of what? Of oxygen, okay, and have an angle of 104.5. Now, the reason why this water is V-shaped is because of the repulsive force. Now, this water has what? There's 2 lone pair of electrons here, okay, 2 lone pair of electrons, 2 lone pair of electrons here. Okay, because of this, there's a repulsion between the hydrogen and what? And this lone pair. That is why water do what? Is V-shaped. Don't forget that water is not a linear shape, because this is one of the questions in JAM. Okay, water is V-shaped because of what? The repulsive effects between the lone pair, 2 lone pair, and the hydrogen atom present. All right. Now, what are the physical properties of water? Very simple. You know this. Look at the screen very well. The boiling point, the freezing point, density. Water is neutral. Pure water is colorless, odorless, and a tasteless substance. All right, chemical properties. Water can react with metals, okay, to liberate what? Hydrogen. You can see it here, very clear. All right. Okay, very hydrogen gas. And I can also react with this, but this one should be in, do not react with cold water. All right. All right. Look at this. This one react with steam, but CuHu do not react with water to form alkali because what? This thing is below. All right. This one is below hydrogen, so they cannot really react. They are weak metals. All right. Okay. Now water can also react with chlorine. All right, with chlorine to give us what? HCl. We call it hydrogen oxychloride. All right. Now, what is hard water? This is where I'm going to. Water that forms scum with soap is called what? Hard water. That it does not really lather very well when soap is used. What causes it? Because of the presence of what? Of magnesium and calcium ion in the form of chloride, sulfur 6, and carbonate 4. All right. So it causes scum. There is no, that doesn't lather very well with what we so we call the word hard water. Look at the screen, you will see example with this. This is magnesium and what? And calcium. Okay, hard water, yes, this water contains what? This ion. So this water is hard. Okay, it's hard. It cannot lather, it cannot foam very well with soap because of the presence of these ions that are present. These are another examples of hard and soft water. Soft water contains low mineral salts, but hard water contains more. Okay, so soft water can foam very well. All right, what hard water cannot foam very well. Now we have two types of hardness: temporary and what? Permanent. This is another jam question. What causes temporary hardness? Temporary hardness is caused by the ions of magnesium and calcium, but in the case of HCO. Now, in temporary hardness, this H must be there to be temporary. All right. If you remove this H, is what is permanent hardness, because this compound can be decomposed, can be removed by boiling. For example, if you boil temporary hardness, okay, you can remove it. So you can see now, and gets back at what? Our permanent hardness. So by addition of slaked lime, this is the equation for removal of temporary hardness of water. Okay. What are the effects of this? This temporary hardness can cause forming of kettle and boilers and stalagmite and what? Stalactite. You can see forming of kettle. All right, you can see how this kettle is looking somehow. This is because of what? The water is hard. All this is because of what? The water is hard. It falls this. All right. So let's move on. Stalactite and stalagmites. All right. This one grows upward and what? And downward in a cave. The one that grows what? Downward is called what? Stalactite, while the one that grows upward is called what? The stalagmite. Okay, now let's go on. Permanent hardness. How is it caused? By the presence of calcium and magnesium. Okay, in terms of sulfate, I've said it before, sulfate, chloride, and also what? Carbonate 4 salts. You can remove them by what? Using a washing soda. You can see on the screen, this is washing soda. Okay, this is what caustic what? Soda to remove permanent hardness. You can also remove by using what? Distillation what? Process, or by addition of permutate. It's called ion exchange what? Resin. Advantages: forming of kettles, it wastes soap, it cannot be used in dyeing and tying. The calcium magnesium octadecanate causes dulling of white what? Fibers. All right. Difference between soft water and hard water. Look at the screen. It displayed. Look at it critically. They are all there. All right. So let's move. So how can we treat water? Very good. Now there are some substances when you add to water that is very good for what? If the water was unclean, it now changes the form of the water to a clean water. The first of all is adding what? Potash alum. What is the function? This causes what? Coagulation. That is, it makes the dirt to cluster, so you can easily filter them off. After then, you have what? Sedimentation. Now, what means that the dirt will settle for proper filtration. All right. Now, you have passed through water through a filter bed, okay, to filter out the part that flux or coagulates. After then, you now apply your disinfectants. It can be in the form of chlorine. Now, what's the work of chlorine? You will notice that most people that use that owns a swimming pool, they add chlorine to the water to do what? To kill germs. So that's the main work of chlorine in water, to kill germs. The iodine is to do what? Is to prevent simple goiter, all right? Whereas the fluorine here is used to what? To prevent what? Tooth decay, all right? So after this is done, your water is now set, okay, for drinking, all right? So this is the diagram for the purification of water for home and domestic and other uses. Okay, let's move to test of water. It's very simple. How do you test for water? When an anhydrous cobalt chloride changes from blue to pink, as you can see on the screen, all right, this is our cobalt 2, blue in color, all right. When there is water here, it now changes to what? To pink. That means that water is present in that substance. Another test is what? When you now add water to an anhydrous white CuSO4. This is your CuSO4, okay? When water is added to it, it now changes the color to what? To blue. So this equation on the screen. So this is another aspect of asking question from water. Okay, let's move to solubility. Here we have three basic stuff. The solutes, which is your solid particles, the solvent, which is your liquid particles, and your liquid substance, and the solution. Now, when you add your solvents, when you add your solutes, as you can see on the picture, when you introduce any solute to solvents, it becomes what? A solution. All right. So, then what is solubility? All right. Solubility of a solute in a solvent at a particular temperature is the maximum amount of solute in moles or grams that will dissolve in 1 dn cube of solvent at that temperature. Now you can be asked to solve this. So this is a simple mathematical expression to solve solubility. Very straightforward. This, and this. Okay, so let's move to some classes of solutions. The first one here is called saturated solution. We also have unsaturated solution. Then we have what are they? Now let me use this diagram to illustrate this. Now look at the first diagram. The first diagram is called what? Saturated solution, in which this solution can dissolve less solute below what? Its saturated point. That means that it can still dissolve more solution in unsaturated at that temperature. All right? That means that the particles are fully dissolved in the solvent. They have low solute. But saturated solution will dissolve more solute, okay, at that temperature. That means that this one will not, the solid will not dissolve completely in the solvent at that particular temperature. You will see contains some particles of undissolved solute, okay, in the solvent. You call it what? Saturated. Then super is when we have exceeded the what? The saturated point. You added more of the solutes, okay, to your solvent, and the solution becomes so thick so that even you can notice the crystal. We call that word a super saturated solution. That means that you have the solute above the temperature. The next one is your solubility curve. This curve shows, okay, relationship between solubility and temperature. As you can see on the screen, we have different samples, okay, different salt with their different solubility with regards to their various temperature. The next slide will show us their induction, their interpretation. Now look at this. This one is typical WAEC JAM NICO question. Now look at this curve. Look at sodium chloride. They will give you a curve like this and give you to interpret. Now this is a few interpretation about this curve. The first one, solubilities of potassium chlorate. Where is it? Potassium chlorate, see it here, all right? And potassium dichromate, where is it? See it here. And then, yes, potassium triazonitrate, see it here. What happened to it? This increase with rapid temperature. You can see the curve going from 10 to above, okay? They increase rapidly because of the increase in in temperature. All right. Now look at this other solubility of sodium chloride. You can see now it's a straight line. Okay, so that this one is independent of temperature. You can see it's flat. Whether you increase temperature or temperature is low or is higher, is still where it is. All right. So this one is independent. Okay, independent of temperature. You can see that is why we have a straight line in this solubility curve. All right. Now, if you go down to the next one, you have what? Solubility of potassium chloride. Where is it? See potassium chloride here. See in the curve from this point to this point. So what is the interpretation? All right. This increases at constant rates with a rise in what? In temperature. Very constant. That's why you have a straight line. Constant. Another one is sodium what? Nitrates. Okay. Constant rates increases. So take note of this. You will see, they will give you a diagram and ask you some question concerning this curve. So you have to pay attention to the question and look at it very well before you now pick your option. Now let's move to something else. Application. Please look at the slide. You check what they have been used for in pharmacy, okay, for research work, and also for fractional crystallization. We have different types of solution. We have what we call the true solution and the false, or what you call it, colloidal solution. Now let's discuss this in the diagram. Now the first diagram here is your true solution, where you have a complete dissolution. For example, if you add a salt to a substance, okay, the salt will not dissolve completely. So you show that you can even dissolve more. All right? No particles is noticed. You call it what? A true solution, otherwise called what? Unsaturated solution, right? Now this is the example of a colloidal solution. You can see this now. All these particles are there, but you cannot see them with your naked eyes, all right? You cannot see them, but they are not completely what dissolved. You call it what? False or colloidal. Now when you talk of suspension, we have larger particles or what? Of solutes. You can see now. This one you can see through. You can see the particles that they are not really dissolved. All right, this one can be in form of starch and so on. All right, so let's proceed. Okay, the next thing I want to show you is some questions that regard solubility. Yeah, some questions that regard solubility. How JAM asks your question with solubility. They can give you a particular question and ask you to calculate the solubility of that particular salt. Okay, let's take for example question 1 here. Yes, 3.06 grams of a sample of potassium triiodochloride 5 was required to make a saturated solution with 10 cm³ of water at 25 degrees Celsius. Find the solubility. Now in this case, I've given you formula. I've solved it in two forms. So you pick the one that is most convenient for you to apply. But since you are writing OBJ exams, I prefer you use this option 2. Use the alternate question. Pick the parameters carefully, okay, and insert it on their formula. You get it. Like the mass of a molar mass times 1,000 all over volume. This is a simple formula of solving solubility, all right? So this is your reactive mass in the question. The molar mass of the salt times the volume times 1,000 over volume. When you do that, you're going to have 2.5 mole. So that is, you go to the option, you see that, yes, the option there is C, 2.5 moles. Okay, 2.5 moles. Now question 2 is same thing. Just go straight, use the formula. It's very easier for you because it's OBJ. You're writing, you don't have much time, all right? So when 50 cm³ of the solution of sugar at this temperature was evaporated to dryness, 34.2 grams dry of solid was obtained. What is the solubility? Very simple. Pick your formula, which is mass over molar mass times 1,000 over volume, all right? Now look at your molar mass. What salt is given? They give you the molar mass already. 342 grams is your molar mass. Now what is the reactive mass? Reactive mass is given in the question as what? 34.2. Do what? Make your direct substitution, all right, and multiply out. Very straight way. When you do that, you're going to have 2.0 mole per dm³. All right. So this is a simple question too. In the purification of town water supply, alum is used to calculate the small particles of what? Mud. That is to make the particles of water don't calculate, so you can filter them out. That is the function of alum. What of chlorine to kill germs? What of iodine to prevent simple goiter? What of fluorine is to prevent tooth decay? So note all the function of this. They can pick question from there to ask you. Question 4 says, which of the following water samples will have the highest titer value, which is titrated for the calcium ion using soap particles. What does that mean? This calcium ion is a cause of hard water. So the answer there is what is A. Permanent hard water after boiling. All right, it will still contain calcium even when you boil it, because calcium causes hardness of water, either permanent or what, or temporary. So the answer there is what is A. All right. 5 says which of the following processes do not take place in domestic water treatments? Answer is what is C. Neutralization. Others are there. We have chlorination, we have flocculation, we have sedimentation. All right, so we have other questions here. Please look at the slide very well. The answers are being identified. Then solve question 8 as your assignment, okay, to check if you really follow what I've taught you so far, okay? Just make your solubility sort of equation, substitute the mass, the molar mass, and the volume. You get 1.25 for question 8. Just try that, you get the answer. Then smoke consists of solid dispensing what? In dispensing gas. All right, so other questions are there. Go through it very well, all right? You know how to tackle it. It's very simple stuff. Don't allow this to intimidate you. Follow it critically. You get your answer right. Another questions are there. Question 11, question 12. Colloidal, a property of colloidal solution is, answer there is Tyndall effect. When the light scatters, all right, when you pass through, if a solution is a colloidal, is a false solution, if you pass a light to it, it will scatter. So that process is called what? Tyndall effect. So the answer there is what is A. All right. So other questions are there. Just check the slide carefully. All these are JAM questions. So please go through the slide, listen attentively, and study it carefully. I promise you, you will get not less than 95% in chemistry. Thank you, and God bless you.